Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azizi Aswad bin Hisham. My matric number is DA180187. Okay, now I'm going to explain about my project, my final year project 1. That is the comparative study of the buck boost and SEPIC converter for 12-volt LED driver application. My supervisor is Prof. Madya, technologist Dr. Asmarashid bin Ponniran. Okay, my panel is IR Dr. Rahisham Bin Abd Rahman and technologist Muhammad Nafis bin Ismail. In this presentation, I'm going to explain about the project background, problem segment, methodology, and the preliminary result. Okay, firstly about my project background. Okay, LED driver. What is LED driver? LED driver is a specialized device that rectifies high voltage alternating current into low voltage of direct current in order to operate the light emitting diode. It also known as the LED power supply. Okay, this driver had the same function as ballast for fluorescent lamp or the transformer for low voltage bulb. Okay, for the problem segment, since the voltage source of LED driver is run in low voltage, it needed DC-DC converter that convert high DC voltage into low DC voltage without having high output ripple for the driver to run efficiently. Okay, this is the image of buck converter which did decrease the voltage from 170 volt into 12 volt. Okay, the buck converter is one of the converter that can reduce output voltage from high input voltage, but the buck converter will create high output ripple. When the output ripple is high, the device will not run efficiently. Okay, for the possible solution, for the buck converter is use high number of inductor value, because when the number of the inductor is increased, it will decrease the output current ripple for the circuit, but it will increase the internal resistance for the system, and in the end, the circuit will not run efficiently. Okay, for the objective, the main objective in this research are to analyze the difference of buck boost and SEPIC converter in terms of output waveform by optimizing the ideal parameter for the output ripple improvement. Next, to develop the integration between full wave bridge rectifier with SEPIC converter in order to convert AC to DC voltage for the LED driver. And finally, to determine the performance of LED driver based on the output waveform of the SEPIC and the buck boost converter. The scope in this project will be limited to the following. Okay, first, the Plex software is used as the simulation software. Next, the full wave rectifier is used as the AC-DC converter for converting the AC voltage source into the DC voltage output. Okay, the switching frequency for the buck boost and SEPIC converter is 50 kHz, and the MOSFET is selected as the switching device for simulation and the prototype. The pulse generator is used to provide the signal pulse for the simulation in Plex. The duty cycle for theoretical verification and simulation is decided based on the voltage output from the DC-DC converters. The RMS voltage of AC source is 230 volt, and the output voltage DC is 12 volt for the calculation and the simulation purposes. The design of the buck boost converter and SEPIC converter is run in the simulation in order to compare the voltage and output current ripple. The issue in the DC-DC converter are focusing on reducing the voltage and current ripple of DC voltage. Okay, related issue in DC-DC converter. For the integration between rectifier and converter, I am using full wave bridge rectifier to convert the input AC voltage into output DC voltage. And for the output ripple issue, I'm using two low output ripple DC-DC converters. Next is the methodology. Okay, for the methodology, this is the block diagram of the system. Starting from the AC source to the rectifier. The rectifier is functioned to convert the AC voltage into the DC voltage, and the DC-DC voltage. DC-DC voltage is functioned to convert the high input voltage into the low output voltage. Okay, next, this is the full wave rectifier that I will use. Okay, for the flowchart, firstly, we're going to do the research about the converter. Next, we identify the converter to find out which converter is the suitable converter that can generate low output ripple. Okay, next, we design the simulation of buck boost converter and the SEPIC converter using Plex simulation. and after that we record the result and analyze the result based on the research paper. Next, if the output of the converter is meet the requirement, we go to the discussion and conclusion. But if not, we going to back to the design and simulation of the buck boost converter. Okay, next, preliminary result. Okay, this is the buck boost converter that being run in the flight simulation. Okay, this is the preliminary result for the buck boost converter. On the left side, it was the switching frequency of the buck boost converter when the duty cycle is at 6.63%. Why we use 6.63%? Because for the input voltage of 170 volt, we use 6.63% of duty cycle to get the 12 volt output. Okay, on the right side is the voltage output for the buck boost converter. The buck boost converter will generate negative voltage output. Okay, next, this is the current ripple and the voltage ripple for the buck boost converter. On the left side, this is where the voltage ripple from the capacitor and the output of the buck boost converter. On the right side is the waveform for the current ripple from the inductor and the output of the buck boost converter. Okay, next, this is the SEPIC converter circuit that I built in the Plex simulation. Okay, for the SEPIC converter, okay, this is the switching frequency for the SEPIC converter when the duty cycle is set at 6.63%. The SEPIC and the buck boost converter has the same calculation of the duty cycle. So the duty cycle for the buck boost and the SEPIC are the same. So to get the 12 volt output. Okay, on the right side is the voltage output from the SEPIC converter when the duty cycle is set at 6.63%. The output voltage for the SEPIC converter is in the positive polarity. Okay, on the left side, this is where the waveform of the voltage ripple from the capacitor 1 and output of the SEPIC converter. On the right side is the waveform of the current ripple from inductor and output from the inductor 2 and output of SEPIC converter. Okay, this is the DC-DC converter comparison between buck boost converter and the SEPIC converter. Okay, the number of passive component is for the buck boost converter is 4 and the SEPIC converter is 6 because the SEPIC converter is because the SEPIC converter needed an extra inductor and capacitor to be run efficiently. Okay, for the output voltage from the calculation is negative 12 for buck boost converter, and for the SEPIC converter is 12 volt. Okay, this is switching frequency for the time on where for the buck boost converter. When the T on for the buck boost converter is 1, for the SEPIC converter is 1.3 microsecond. While when time off for the buck boost converter is 19 microsecond, and for the SEPIC converter is active on 7 microsecond. Okay, the output voltage from the simulation is for the buck boost converter is negative 12.0707. Meanwhile, for the SEPIC converter is 12.0669. Okay, the input current ripple for the buck boost and the SEPIC converter is the same, 0.23 amp. And the output current ripple for buck boost converter is 16 micro ampere, and for the SEPIC converter is and for the SEPIC converter is 15 microampere. And for the input voltage ripple for the buck boost converter is 8 microvolt, and for the SEPIC converter is 1.0 microvolt. Okay. Lastly, for the output voltage ripple for the buck boost converter is 0.8 microvolt, and for the SEPIC converter is 0.7 microvolt. So in this comparison, we can say that the SEPIC converter is the most suitable converter that can run the LED driver because it has low output current ripple and low output voltage ripple for the system. So the system will run efficiently. That's all for me. Thank you.